Welcome to another edition of Math Notebooks. Today we're going to be continuing geometric transformations, talking about rotations and dilations. This is a continuation, and I would suggest it be put just behind the page that we did last week on geometric transformations with translations and reflections. Title it Geometric Transformations. You'll need this piece of paper, pencil, maybe some different colored pens. You're going to need glue and scissors as well. And so let's start by cutting out these images right here. So now that we have both of these cut out, we're going to set this one aside and first talk about rotation. First, the definition of rotation. I'll write it down and then we will go over it. The definition of rotation is turning an object around a point called the center of rotation. Now let's glue this down and get to work. So this task asks us to graph the rotation of triangle ABC 90 degrees clockwise around the origin and 180 degrees around the origin. And so the origin is our center of rotation here. And remember, that's this point here, 0, 0, right in the middle. And to demonstrate what this looks like here, I've cut out a little image. And so this is just a copy of this. So I'm going to hold this over here, and I'm going to talk about what happens if it means 90 degrees clockwise. Well, that means I'm going to stick my finger here and keep the origin point at the origin point. You could even use a little pen. So I'm going to place this right here, and let's see what happens. Let's just focus really quickly on point B. So point B is at -3, 1, 2, 3, 4, 5. So -3x, 5y. And as we rotate this 90 degrees, keeping the origin right there, now let's look at what happened to point B. Now point B is at 5x, +3y. Very interesting. So in that rotation, what ended up happening is our x-axis, our x value, changed. It went from -3 to +5. So actually the x and the y ended up switching there. It was +5y, now it's +5x. And the x and the y also switched, so it was -3x for B, and now it is +3y. So the y sign changed and it switched with x. So pretty cool. Let's go ahead and graph this really quickly. And another way we can see this is we can take a color here, and let's think about the origin as our point of rotation. And so everything is rotating in a perfect circle around this origin. So point C, I'm going to kind of draw a partial circle here, and point C is going to end up right here. So point C went from -2, +2, and they switched, and now it's +2, +2. This is our new point C, and we'll put C with a little apostrophe over it to indicate that that's our new point C. Then in blue, let's talk about B. So B is going to kind of come over here, and we will know that since it was -3, +5, we're going to switch. So X is going to become the Y. So +5, X, 1, 2, 3, 4, 5. Now is our x, because that was the y. And then the old x was -3, and that's going to become +3y. So the new B is going to be right here. +5, +3. So that's our new B right there. We can kind of see how that works. If we were to kind of draw our circle going around, it takes that same arc to get our new B. And then A, the x was -1, 2, 3, 4, 5. So the new y is going to be +5. The old y was 1, 2, 3, +3. So the new x is going to be +3. So here we can see, let's just talk about A. It went from -5, +3, and the new A with an apostrophe is going to be +3, so the y became the x, and then the x value changes signs and it becomes positive 5. Let's go ahead and plot that. 3, 5, so 1, 2, 3, 4, 5. It's going to be right there. That's going to be our new a with an apostrophe. And if we take our straight edge, which I have forgotten, give me 1 second. There it is. Take a little straight edge, and I'm going to connect it with a different color here, red, to indicate that this is the rotation. We should have the exact same triangle, just rotated around the origin. And there it is, just rotated around the origin there. Pretty cool. Now, this should match up with our little cutout. So remember, we started here, and so our new shape should be there. Let's see, does that look, oh, yep, that looks identical right there. So now it's saying the second thing we want to do is 180 degrees around the origin. So again, we're going to keep rotating, and our image should ultimately look like this. So C will be there, still at positive 2, negative 2. A, the new A, is going to be at positive 5, negative 3. And B is now going to be at positive 3, negative 5. All right, so let's go ahead and plot those. So C, if we continue our origin, or our rotation around the origin, it's going to end up right there. So here's our new C. B will also continue, and so let's go over here, right, 180 degree. So this is our 180 degree rotation. And let's think about point B. So point B with 1 apostrophe, we're going to do, well, actually, let's start from the original. So point B, what we're going to notice is from our original, if we rotate all the way around the origin, what's going to happen here is that, let's talk about point C. It went from negative x, positive y, negative 2, positive 2, to positive 2, negative 2. So you're going to notice for both the x and the y values, they're going to switch signs here. Same thing for B. So B original, so just the original B, it was at negative 3, positive 5. And when we do a 180 degree rotation, that's going to go to B with 2 apostrophes. So our new B, when we do a 180 degree rotation, the signs are going to switch. So the negative 3 is going to become positive 3, and the positive 5 is going to become negative 5. And sure enough, that works. When we do this rotation here, 180 degrees, now we have positive 3, negative 5 for B. And it's going to be the same for everything else. So our original A was negative 2, positive 2, and that becomes our A with 2 apostrophes. It's going to be positive 2, negative 2. And then C originally, or wait, no, that was C. And then A originally was negative 5, positive 3. And in a 180 degree rotation, sorry, that was C, it's going to be flipped. It's going to be positive 5, negative 3. We just changed the signs. So let's go ahead and plot those. And there you have it, a 180 degree rotation. Now let's move on to dilations. I'm going to write the definition down, and then you all can do that after me. So dilations are a transformation that changes the size of an object, but not the shape. We're going to glue down this little piece of work underneath. Our problem today is going to be graphing the dilation of rectangle HIJK, JK by a scale factor of 2 using the origin as the center of dilation. So we're going to imagine the origin right there, and we're going to shoot out from the origin, and we are going to make a scale factor 2 copy. So the new image is going to be scale factor 2. All the side lengths are going to be multiplied by 2, and it's also going to be twice as far from the origin. And this is kind of cool. The way that this works pretty well is we take all of our points, and all we do is we multiply them by 2. So I'm going to write down all of the points here, and then we multiply by 2. So our original points are here, and to make a proper dilation with scale factor 2, all I'm going to do is I'm going to multiply the x and the y coordinates for every point by 2 and get my new points. So let's check that out. New points, all multiplied by 2. Now let's plot them and make sure that it still looks like a 2 times scale factor object, and the way we're going to test that is like this side here is 2 tall, so in a 2 times scale factor object it should be 4 tall. Let's just see if that works out. All right, so our new points here are h at 2,6, I at 10,6, j at 10,2, and k at 2,2. We'll just kind of shade these in now and check it out. The new height for like HK is 4. The old one was 2, so that is a scale factor of 2. It doubled. The old width was 1, 2, 3, 4. The new width is 1, 2, 3, 4, 5, 6, 7, and 8. And it's perfect scale factor of 2. Awesome work. I hope that helps make sense of dilations. That's how you do them, and reflections. Have a great rest of your day.